stand on my back.
Good evening. I'd like to welcome you to Oceans Alive. Tonight's lecture wraps up our 13th series, so I thank you all for coming, and I'll look for our mailings next year. If you're not on our mailing list, please stop and see me on the way out, and we'll make sure we get you on the list. My name is Tracy Crago, and I'm the communications person at Woods Hole Sea Grant. Judy McDowell, our director, couldn't be here tonight, so she asked me to introduce our speakers. We actually have a tag team to address you tonight about this issue. And the first person you'll hear from is Brad Morse. And Brad is a cranberry grower in Rochester, Massachusetts, a fifth-generation family-owned business, the Double M Cranberry Company. And in addition to being an ocean spray grower, he right now has 47 acres in production. And the pilot project he'll talk about tonight is on a 1.4-acre parcel. After Brad addresses you, we'll have questions for Brad because he actually has to leave early. He's on frost patrol tonight, which I guess he just mentioned means sleeping in a pickup truck and making sure the bogs don't freeze. And after he entertains some questions from you, Dale Leavitt will be speaking. Dale is a aquaculture specialist for the Sea Grant program and also the Southeastern Massachusetts Aquaculture Center, or CMAC. And CMAC is one of the partners in this pilot project. Dale is also a scientist who came to Woods Hole about 20 years ago and never left. He's one of those. But Dale will be talking about the CMAC and the aquaculture industry portion of this pilot project, and they'll both be willing to answer questions after. So without further ado, here's Brad Morse.
Actually, here's Dale.
We just did this to confuse Tracy. Before we get started, I just wanted to acknowledge the third correspondent that's on our title page here. Ken Bergstrom is actually the director of the Western Massachusetts Center for Sustainable Aquaculture, which is located at Hampshire College. And this whole thing that we're going to be talking about tonight, the partitioned aquaculture system, is based on some early discussions with Ken and some very astute observations that Ken made way back when they were first developing this technology, and how it might have some good applications here in Massachusetts. So I just wanted to acknowledge Ken's contribution in this, even though he couldn't be here with us tonight. So on that note, I'll turn the floor and the mic over to Brad.
No. There we go. I'm just going to give you a basic overview of my business and the cranberry business as a whole. My actual business is 47 acres of bogs in production. There's 100 plus acres of upland and reservoirs and swamps around it. Produce approximately 160 barrels to the acre. A barrel is a 100-pound unit of cranberries. I'm a process grower, meaning most of my fruit goes to juice and sauce. The other option is fresh fruit, which is dry harvested, which is the fresh fruit market. My bogs have been in existence since the 1900s. In Massachusetts, there are roughly 1,000 growers. 1,000 growers in North America, and 500 in Massachusetts. 14,000 acres of cranberries in production in Mass. That number's growing still, even though the current economic conditions. There's another 48,000 of upland and supporting wetlands. Roughly around 2 million barrels, I think this number's a little low, of cranberries were grown in Massachusetts. 200 million in payroll to Massachusetts workers and employs approximately 5,500 people. That number's probably dropped substantially in the last 3 years. The multiplier effect to the economy is estimated to be over $1 billion. This gives you an idea of the actual piece of the pie that Massachusetts plays in the United States production of cranberries. Canada is a big player now, with Quebec and British Columbia coming online with a lot more production. Cranberry farming. This is a bog that's kind of out of focus. This is the spring, when the bogs come alive. which is what we're doing now, is protecting the bogs as they're coming out of their winter dormant stage. Sometime around Father's Day, they start going into the blossom stage, which is how they supposedly got their name, because the blossom looks like a crane. During the summer, we're protecting the fruit from insects and fungi and weeds, and feeding them nutritionally and watering them and doing the horticultural practices needed to keep the fruit going. And then we reach the fall, which is harvest time. This is water harvesting. And this is another water harvesting. And then comes winter. The bogs are flooded again, and ice is formed to protect the plants from New England's winters. We also sand on top of the ice about every 3 years. The reason for this is to basically, like you prune your shrubs, we're burying a little bit of the plant, promoting new growth. The current state of the industry. The average production costs somewhere around $40 a barrel in Massachusetts, not including debt service to banks. Last year, we got paid around $10 a barrel, the last 2 years. The projected for the next 2 to 3 years is we're not going to reach even $35. We're being asked this year by the USDA, we're under a marketing order to reduce our production by 32% to cut down on some of the surplus sitting in freezers around. Why do we have such an overproduction? Over the last 10 years, there's been vast expanses in the cranberry acreage throughout the whole world. A lot of the new varieties are what we call hybrids, which produce a lot more berries to the acre than the traditional Massachusetts varieties. And we need to develop new markets, which we laxed on a little bit in the last 10 years, and that's the reason we're in the state where we are. With all the increases in production, we didn't have an increase in selling the actual fruit. And to diversify crops. Why do we need the cranberry industry? Probably the most important thing is the economic contributions to the area. Open space protection. Vast tracts of upland are owned by the growers to protect their bogs. This is all being slowly sold off as we're in this economic state that we're in to house lots and other entities. Aquifer recharge areas. We maintain ponds, reservoirs, swamps, and these are all controlled by the growers, which also provides flood control to this area. When we see rain coming, we pull our reservoirs down, and we also hold a lot of water throughout the season to harvest and for general irrigation during the summers. There are a number of different things we're looking at for cranberries. These are some of the things that other people are looking at are grapes, beach plums, which I'm also looking at, late season strawberries, which will be grown on the bog. The other two are grown in the upland surrounding the bog, and blueberries and fish. And on that note, that's my part of the presentation. Any questions?
Brad, as Tracy said, Brad's got to run probably before I'm done to tend to the bogs because there's a frost threat tonight. So if you have any questions for him, now's your chance because he may not be here by the end.
What is the source of the water? Are you drill wells all the time? And where does the water run off to?
Most of our water is surface water. In the years when the bogs were built years ago, they were a lot of old river basins, and they built actual dams across them, forming these swamps or reservoirs. And then the bogs would be built in stages. Below that, and then there'd be another dam with more water collected for the next grower. So most of it's holding surface water. There are wells, I do have wells on my site for years when there's serious droughts, but a majority of it is surface water.
It's my understanding that in Falmouth, a good part of the Cranberry Bog areas are owned by the town of Falmouth. Is that common to the rest of Massachusetts, or is that a rare condition?
Not yet. Not at this time anyways. That's rare.
That's rare.
Mhm. There are a few towns that conservation agencies own some, and that's another option that some growers are looking at, is ways to put their land into conservation easements. So.
Well, cherries are not cranberries. Last week I heard about a cherry concentrate that was being used as a treatment for arthritis. And as we know, there are a lot of alternative medications for that. So I'm just wondering how cranberries would do as antioxidants in a concentrated form. There seems to be a considerable demand for these cherry concentrates, but again, apart from the color, I'm not sure how they compare.
Well, my cooperative, which is Ocean Spray Cooperative, which is a grower owners cooperative, probably about 10 years ago marketed a study that was done on urinary tract infections, and that was one of the things that led to a huge increase in the demand for cranberries, which caused the influx of all the cranberries to be planted. Since then, there's been lots of studies that have come out on benefits to the heart and other things, and that will be used as a marketing for cranberries. It's kind of, you don't want to advertise medicinal values from a natural fruit too much. In other words, they've backed away from using that as a marketing ploy, even though there are definite health benefits.
If you're going to be able to use the bog for growing plants on, how does this completely destroy the cranberry area, or can you live in between things, or suppose it can be put back into cranberries again? What's the time frame?
For these other, going back to these other alternative crops, the grapes would be grown around the edges, up in our sand pits or on our woodland, upland that we have around it. The beach plum's the same thing. The strawberries would actually, I don't know enough about the strawberries to even speak on it, but I believe the bogs are being stripped and then the strawberries are planted. By being stripped, I mean removing the vines. Including in our fish, we're going to be removing the vines from the actual bog surface, because the bog will be flooded throughout the whole summer, which would kill off the vines anyways. To put it back into production, basically what I'd do is go out and spread 6 inches of sand and put vine cuttings back out, and in 3 to 5 years I'd be raising a crop again.
20 or 25 years ago, my son was working on fish farming in the Philippines. I never followed it too much, but I thought that it was salt water they were using. I never got involved in it, only I heard that he worked there. He was there for a year and a half or 2 years. He's out of state now anyway, in Alaska. Can they use salt water for this or no? Not in the bog.
Not in my location. On locations on the Cape, yeah, it would probably be an option, but you probably wouldn't want to do that for the reason that once you brought salt water in there, you'd never be able to put the bog back into a cranberry bog.
What about conservation commission regulations, approval, and all that kind of stuff?
We're still working through some of these issues. We haven't gotten through all the.
What are some of the pros and cons?
The pros and cons?
You mean about fish culture specifically, or just
Well, I
taking
mean,
the bogs out of cranberry production?
Utilizing the cranberry bog for some other purposes, but it was originally approved by the conservation commission.
I think it depends on what the initial permits were for that specific bog. Some of them have grandfathered in from the old bogs that were put in before there were any conservation restrictions or orders, conditions placed on them, where the newer bogs are are in place with Conservation Commission oversight. So it's a gray area where we have some farm planners that are working on that as we speak right now.
Could you raise fish on part of the bog and still keep part of the bog and
The fish part I'll get to. I've got another whole, probably a lot more than you ever want to hear about fish culture in the next 45 minutes or so.
Frank, you said you sell your cranberry mostly for juice.
Juice and sauce. Any berries that are harvested in the water in Massachusetts go to the processed market. They're frozen and then squeezed for juice and concentrate. The fresh fruit market, which is it's a small market, but it's a viable market for Massachusetts because of the quality of our berries, are the dry harvests, the old scoops in the old days, but now we have mechanical harvesters which do harvest that way. I currently do not do that. I'm a one-man operation now thanks to the economic conditions of this industry. And water harvesting is the easiest method to harvest the bogs.
And do the various products different per barrel prices, or do you get the same amount with
You get incentives to pick, in our cooperative, our payment schedule. We do get more for picking to pick fresh fruit, as well as in the outside market. They do get more per barrel. The damage to the bogs are your production drops, for the most part, down. It's a lot harder on the bogs. You're running over the bogs with machines, whereas during the water harvest, the actual beaters don't put that much ground pressure on the bogs and they don't hurt the vines as much.
How does nutrient fertilization in cranberry bogs compare with other types of agriculture?
Pretty similar. I'm also a citrus grower in Florida, and basically as far as pounds of nitrogen per year, it's pretty much the same, and that's also a fruit. It's just a tree fruit. Just down there it leaches out of the soil much faster than the peat soils we have up here.
Why don't we, we'll jump into the fish part, and then if I do it real fast, you just stick around. Play it by ear. Okay, I'm going to talk a little bit about the aquaculture side of fish in the bog, and I'm going to talk specifically about a system that's called the Partitioned Aquaculture System, or the PAS system for growing fish, and you'll see a few other crops as well. Basically what we're trying to do is we're trying to look at alternative uses for cranberry bogs where we don't run the risk of permanently removing the potential for cranberry production. Someday down the road, cranberries may jump back up to $85 a barrel like they were 5 years ago. So we want to be able to give cranberry growers the option of putting their bogs back into cranberry production if that should ever occur. But on the other hand, these folks have to live. They got to make a living, and so we've got to give them a system that they're going to be able to make money from. Probably the first question that I like to put up when I'm talking about these kinds of things is how can aquaculture compete with wild fisheries? How are we going to make money, particularly when we're competing against a wild fisheries program? And so there's a few numbers that I'll throw at you just to sort of explain where we're coming from. If you were looking at a freshwater pond somewhere around here, about a 1 acre pond, if you went and harvested all of the harvest-sized fish in that pond per year, you'd be able to pull about 100 pounds of fish out of the wild pond. If you went in there and started controlling the species composition, so you're actually optimizing fish at the different trophic levels, then you might be able to pull your production up to around 500 pounds per acre. This is in comparison to beef cattle production, which on the average in the U.S. is around 600 pounds per acre. If you were to take that pond and convert it over to a monocultured system, and these numbers are primarily generated by the catfish industry down south, but if you put this in as a monoculture system with one species that you're now managing,
then you can actually increase that production by an order of magnitude. You're now operating at around 1,000 pounds per acre. If you start doing some water quality management as well as maintaining your monoculture, you now have jumped it up another 5 times to around 5,000 pounds per acre. If you really transform that pond, basically it's not a pond anymore, it's now an intensive fish culture system, but the catfish farmers in down south are generating around 10,000 pounds per acre. So now we've got a 2 orders of magnitude jump in our production by managing the system. And then lastly, with this partitioned aquaculture system, they've been operating experimental versions of this at a level of around 20,000 pounds per acre, and they think that they can probably push that up to around 25,000 pounds per acre. So as you can see, aquaculture offers some real potential for growing food products for us here in the U.S. And at the same time, it may actually serve to take some of the wild some of the pressure off the wild fisheries by producing products for consumers. So, just to give you a little bit of background on fish farming, some important components of being a successful fish farmer. You have to have a good culture system. Water quality is first and foremost your primary concern. Aquaculturists are probably more concerned about water quality than most folks are, because without good water quality, they're not going to be able to grow their product. And they also have to design systems that will give them enough capacity to turn a profit to operate in the black. You have to be careful with what species of fish you're working with to make sure that your markets are there, that your growing conditions are appropriate for the area that you're in, and that you have the technology to manage them. And you also have to have the markets to move your product once you have produced it. Just to give you a quick overview of what some of the parts are of an aquaculture system that one needs to think about. One needs to think about the center fish, the basic reservoir that the fish are being grown in, but you also have to worry about some of the water quality parameters. You have to worry about solids removal, and solids removal as well as soluble waste product removal. The waste products from fish obviously foul the water, and you have to be able to get them out as soon and as easily as possible. You also have to worry about oxygen levels in the water. When you're producing fish at 25,000 pounds per acre, then undoubtedly you're going to have to be providing some kind of aeration or oxygen source to the water in order to meet the metabolic demands of the fish. You also have to worry about CO2 and other water quality issues when you're pushing your production up to that level. So how do we translate all of this technology and these needs into a cranberry bog? Well, we're looking at a system that's called the Partitioned Aquaculture System. It was developed down at Clemson University by an engineering professor there named David Bruni, who I went and visited a while ago to get some firsthand information. It has been applied throughout the U.S. It's being used in catfish culture in South Carolina and Louisiana. There's a very large effort by a commercial striped bass producing firm in California to use the PAS system, and it's been proposed as a system for nutrient remediation in the Everglades down in Florida. I'm not sure where that stands. They were just in the bid process for that a few months ago. Basically what it does is, what we will do in applying it to our cranberry bog is we're going to use the bog as the water conditioning system for the fish. It will not actually be used for growing the fish. The basic design, the PAS was originally designed not as a fish culture system, but as a wastewater treatment system. The fellow that designed it is an engineer. He knew absolutely nothing about fish culture. He did know about water quality and wastewater treatment, and so he designed a biological system, if you will, for handling wastewater. And then somebody came along and realized, and it was based on the use of single-cell algae or phytoplankton to pull the nitrogenous, the soluble waste products out of the water, primarily. Then along came some folks that did know a little bit about fish culture, and they looked at Dave's system and they said, hey, you've got a perfect water quality maintenance system there. Let's put something in there to push it. Let's grow some fish in it. So fish culture was added to this system as an afterthought. And essentially it's a closed recirculating culture system. So basically, once you fill and establish this system as an operating system, the only water that you add to it is to make up for any kind of evaporative losses or losses due to seepage through the pond surface or the sediment. What that does is it gives you a lot more options in terms of what you can grow and what you can't grow, because as a contiguous bordered pond where the actual fish culture system is going to be contained, it gives you more options for holding some of our non-native fish that might be used in aquaculture. Although I don't think that's really an option here in Massachusetts, because we can't maintain the water temperatures that we need for some of the more popular non-native aquaculture fishes such as tilapia. This is just a very sort of a rough schematic of the design. Basically, I wish I had a pointer. Oh, there is one. Cool. Tim's going to get mad at me because I'm not supposed to walk away from the microphone. This would be what you would consider the bog system. This is a shallow water pond used for water conditioning, where the fish holding system is actually built in as an addition to the system. To look at it just as a schematic, this is your fish holding system, which is built in this case, is raceways at the foot of the pond. Then the water is moved through the fish culturing system by a paddle wheel, and I'll talk about that some more, and then through the shallow water Cranberry Bog in this case, so the water conditioning system, which has been baffled to really increase the residence time of the water in the shallow water pond before it flows back into the fish containment area. Whoop. This is what the original PAS system looked like. It was built as a wastewater treatment facility. This is a very small scale. I think this is, it's not even 1/8 of an acre. Basically the system, this is a solid wall, so the system is from this wall over. Paddle wheel drives the flow through our baffled water, shallow water pond, and then it comes into our deeper fish culture raceways down at the end, flows through these screened in gates and back into a solids removal area here, and then the paddle wheel pushes it back out to the pond again. So basically it's a two-part system. The first part is the pond system, and that is maintained approximately at a depth of 1.5 feet. The reason for this is that it allows for good light penetration. And remember that the denitrification or the nitrification system in this pond is based on phytoplankton, single cell algae. And so what you need is you need to maximize light penetration in order to keep the photosynthetic production of those algae up. And they in turn, as they grow, will strip nitrogen out of the water. So by having a shallow depth, you give yourself much better opportunity for light penetration. It also allows the water to warm up much faster in the spring, which is good for us, but the inverse is also true, and that is in the fall it's going to cool down that much more quickly. So there are disadvantages to it being shallow as well. It acts as a biofilter to remove the nitrogenous waste, as I've said. And there are some certain phytoplankton characteristics that you need to maintain in this. Basically, green single-cell algae are good, and the blue-greens are bad. The greens are very high fixers of nitrogen, or converters of nitrogen, and they grow very well in these systems. The blue-greens don't work well. They don't nitrify as well as the greens. But the other thing that they do is they impart an off flavor in the fish. So if you're raising fish as a food product and you get high levels of blue-green algae in your system, it's going to give the fish a real muddy flavor. And then you have to do some kind of post-grow-out treatment to cleanse that blue-green off flavor out of the tissue. Usually you hold them in a clean water system for a week or two to purge the tissue. You can control phytoplankton populations in the partitioned aquaculture system. You can do it through some kind of physical control, and in this case it's the paddle wheel. And you can control the paddle wheel turning, which increases turbulence, allows better light penetration or light exposure to the phytoplankton. You can also control pond depth. You can also do it biologically by putting in organisms that consume phytoplankton. And this is sort of where the research is right now. They're just reporting on some work that was done this past summer where they tried a number of different phytoplankton control systems. And they realized, initially everyone thought that we would just be able to put freshwater mussels in the system and they would filter out phytoplankton and would control the population. But it turns out that the freshwater mussels select the green alga based on size preferentially, so they'll strip the green algae out of the water column, and so therefore you'll get a system that's predominantly blue-greens. On the other hand, they put one of the species of tilapia in, and the tilapia did a very nice job of pulling the blue-greens out and maintaining essentially a green population, green alga population. So there are some biological ways to control phytoplankton populations, and that's one of the things that we're going to be working on this summer, because obviously we're not going to be growing tilapia in Massachusetts.
What is tilapia?
Tilapia is an African cichlid fish, very popular for aquaculture now. It's freshwater, very warm water. It doesn't survive much below 70 degrees Fahrenheit water temperatures, but it's essentially a bomb-proof aquaculture fish and has been very popular. I like to think of it as the tofu of the fish world, because it's a very white-meated fish that doesn't have much flavor. You can buy it locally fairly regularly now, either as fillets or as whole fish. This is a schematic or a view of a quarter-acre PAS system that was down at Clemson, and you'll notice something a little bit different from the original one. This is the paddle wheel. This is two systems actually with a dividing wall separating the two systems. He just piggybacked up the paddle wheels because it's a little more efficient in terms of power consumption. But this big paddle wheel is what drives the flow through the partitioned shallow water pond. And then he realized that he needed to decouple the flow rate through the fish from the pond system, because what was appropriate flow rates for the fish wasn't working very well for the pond. So he put a bypass channel in the design and then put a second paddle wheel in that drives the fish culture system. So he now has a two ways to control flow through the system, the two-part system. In terms of the fish culture system, the second part of it, as I said, it's separate from the pond, separate in terms of the flow and the control. It's actually contiguous with it in terms of water body. And you can produce or put about 5% of the pond surface area into fish production, which, believe it or not, is a fairly significant amount of surface area. We've been doing some calculations for the 1.4 acre bog that we're going to be converting over on Brad's property. And that allows us to put in 9 20-foot diameter round tanks that are 4 feet deep for growing fish, which allows us to grow a considerable amount of fish in there if we crank it up to full capacity. The fish culture system is deeper than the pond system. As I said, routinely they keep the fish culture system at around 4 feet in depth. But remember, everything is done at water level. We do not lift any water to move it from one component of the culture system to the other, which really cuts down on the amount of energy that you use for this system, because lifting in water is very expensive because it requires usually high power consumption pumps. So we just dig the fish tanks a little deeper than the pond itself when we install a system. What you have to be able to do is partition off your raceways or your culture system so that you can hold separate groups of fish. This just makes it easier for the husbandry of the fish when you're actually doing the growing. And we're currently thinking about 2 different growing systems. Traditionally, Dave and the Clemson and all of the other folks have used the square raceway systems, but square raceways have some inherent problems when it comes to holding fish because they have corners. And fish frequently will get hung up in corners or run into them and do damage. So although there's a very large debate that's currently going on in the aquaculture industry, there seems to be some advantage to using round tanks. And so we've actually designed a system that, rather than uses raceways, uses round tanks. And the reason that they use raceways down south is because they're fairly limited in terms of land. And so they have to sort of maximize the amount of surface area they can get out of their plot of land. And they do that by putting in the square raceways because they fit together much more nicely than round circular tanks do. But we have the benefit, the luxury actually, of having quite a bit of adjacent land around these cranberry bogs. So we have the advantage of putting in circular tanks if we want to. This is the fish holding component of a very large 2-acre PAS system down at Clemson. This is the inflow channel. The primary shallow water pond is up here. The water flows into this distribution chamber and then basically runs down this center alleyway canal, and then each of the fish holding systems are located on the side, as you can see, and they each have a gate valve which allows the water to be able to flow independently into each one of these, although all of the discharge runs down linearly to the solids collection area, which is down in this last chamber down here. And then we have the small, the small fish driving system paddle wheels here, and then the much larger pond driving paddle wheels out here. So this is a very large system. 2 acres would give us about 0.1 acre worth of fish culture surface area. This is the gate system for controlling water flow into each one of the fish culture systems. And you can see how productive this water is. This is essentially a green water culture system. Light transmittance, a Secchi disc reading in here is probably less than 6 inches, probably closer to 2 or 3 inches. So you can see that these systems are very highly productive in terms of phytoplankton production. In terms of the water flow dynamics, I've talked about that already, but the pond circulation is driven by a large paddle wheel, which provides turbulence and therefore exposes the phytoplankton to a circular current motion, which gets it up near the surface where they can absorb some sunlight before they drop back down into the deeper water where there isn't as much light transmittance. And it also provides for better oxygen transfer in the water system. The fish system requires a separate controlled water flow. Traditionally, Dave has programmed in a paddle wheel because they're very low energy consumers. We have a system that the cranberry growers use regularly, and we've been using for some shellfish aquaculture that we've been doing in the marine system using axial pumps, axial flow pumps, which also move tremendous amounts of water with very low power consumption. So we're in the process of trying to decide on our pump design for the fish end, whether to go with an axial flow pump or whether to go with the traditional paddle wheel. And then all of the flow rates are based on oxygen content of the water. So you control oxygen content within certain thresholds by controlling the flow rates. And so the whole system can be computerized to run off just 2 oxygen sensors, one for the fish system and one for the pond system. And you can control your flow rates, your paddle wheel turning rates by observing oxygen consumption or oxygen levels. There is a need for aeration, so at certain periods of the night when phytoplankton are consuming oxygen in respiration rather than producing it through photosynthesis, then you have to turn aerators on. Usually occurs around 4 or 5 o'clock in the morning just before daylight. This is the big 2-acre system, and this is the bank of paddle wheels. There's a bank of 4 very large paddle wheels. They're each about 10 feet long that run out across the pond. He now has gotten rid of a lot of the baffling system and has realized that all he needs is one center baffle, so he just turns it into a big racetrack in terms of the water moving in the shallow pond. Fish control, this is just the fish pond paddle wheel. As you can see, they're very simple and easy to build. There's not a lot of engineering that goes into these. They're turning it around 2 revolutions per minute, and they're moving the water at around 1 foot per second, something like that. Why do we think this is a good thing for the cranberry industry? For one thing, it allows the growers to sustain the physical integrity of the bog. The question was asked whether these bogs would be able to be put back into cranberry production, and the answer is yes. The only thing, as Brad said, we're going to do to the bog is strip the plants off. The integrity of the bog, the physical integrity of the bog is going to remain in place. So if anything, what we'll be doing is we'll be adding some nitrogen fertilizer in the form of phytoplankton cell bodies into the sediment. So if at some point they want to put the system back into cranberry production, it's just a matter of sanding, planting cuttings, and then nurturing the plants back to production. It also allows us to utilize the existing skills of the cranberry farmers, which are very extensive. They know how to take care of a living crop, which is something that it requires a very unique set of awarenesses. We've been trying to train fishermen how to be aquaculturists for a number of years, and that's one of the things that fishermen lack. Is not that they can't learn it or don't appreciate it, but they're not used to having to take care of a living animal or plant. And so if a fisherman decides that he wants to go out fishing and wants to leave everything for 2 or 3 weeks, they do that. Whereas a farmer realizes, as Brad does, that he's going to be out there in his pickup truck for the night because there's a frost coming. So cranberry farmers understand how to care for living crops. They're very skilled at water handling and water movement. That's what they do. And they're also very good designers of equipment. And most of these, as you can see, there's some fairly, I won't say sophisticated, but there are equipment needs for these kinds of systems. And the cranberry growers certainly have the knowledge and the abilities and the materials to fabricate the equipment that they need. The cranberry bogs are perfectly suited for this shallow pond system. Most of the bogs around are diked so that they can be flooded at a very shallow level. 1.5 feet does not push the dike systems to any great extent. So we think that that's a really nice adaptation for a cranberry bog. And it also gives us large amounts of adjacent space next to the bogs, the physical bogs, to put in our fish culture systems. So all in all, a cranberry bog is just a fish culture system that's waiting for it to happen as far as we're concerned. This is a schematic of Brad's bog system, and the bog that we're going to be converting into our PAS system is this bog here, which is actually a combination of a very old bog and then a couple of new sections that were added on. You will notice the unique shape of this bog, so when I show you the next schematic, it's going to be based on this because I screwed up when I was doing the initial designs and thought we were working out of this bog. So whatever you see that has this shape, just in your mind put that shape to it and we'll see how it works. Because this is how we've envisioned, this is our first cut at designing the system that we're going to put in at Brad's farm. Basically the bog is in place, has a little bit different shape from this, but the idea is just the same. This is designed with 20-foot circular tanks. They're actually pieces of 20-foot steel silos where you just take a 1 4-foot section of that, you place it down on the ground, you pour a little bit of cement in the bottom of it or something, and then you put a plastic liner on it. So it's a non-permanent installation that has a very long lasting time. We're going to put in some kind of inflow system, probably a large diameter PVC or metal culvert that will then distribute water to each of the tanks. The tanks will have center drains. One of the nice things about circular tanks are they're self-cleaning, and so the water the circulation of the water concentrates all of the solids in the tank in the middle. So if you put a center drain in, then you just you're pulling all of the solids out very quickly. All comes down into a solid settlement basin, which can then be cleaned out, and then the paddle wheel driving the system. And what we'll probably, one of the modifications we're talking about now is continuing this intake channel down so that we can bypass these to control flow into each of the individual tanks, and then put a second pump system in there to control the flow through the tanks. As I said, this was our first attempt at designing the system. So obviously there are unknowns that we're going to have to deal with trying to adapt this southern system to the north. And the first is permitting. the question's already been asked. What happens if we go from bog to fish culture and then they want to go back to bog again? That could be a problem. Some of the bogs are grandfathered in under existing conservation regulations, and if they were to be taken out of specifically cranberry production and put into fish production, they may lose those grandfathered rights. We're not sure. And when we ask those questions, we get sort of fuzzy answers from the state because they haven't really thought about it very much yet. So we're starting to push that button at the state level to try to figure out what their policy is going to be in terms of these transitions. They will still be in farm production, which may be the key component, the key argument that we can develop, that they're not actually being taken out of production, they're being taken out of cranberries. We also have to worry about permitting the fish culture. One of the species that we're looking at, which I'll talk about in a minute, is largemouth bass. Largemouth bass are not recognized as a food fish in Massachusetts, so you can't get permits to grow largemouth bass for food production. So that's something, we think that's an easy hurdle to jump, but we just haven't gotten to that point with the state yet where they're going to say, yeah, okay, you can do it. We have a question about fish species. As I said, this system was designed for catfish and tilapia. Obviously, we can't grow catfish, at least not the southern catfish up here, and we can't grow tilapia here, at least not to any level of production where one could make money. So we're looking at a number of different species that are more appropriate. All native species. The first is a largemouth bass. We think there's a fairly strong market for largemouth bass, and so we're going, and people are starting now to look at them as an aquacultured species. There are fingerlings available from hatcheries, so it looks like it's a pretty good candidate species. The yellow perch is a very attractive fish for growing. There's a huge market for yellow perch in the Midwest. I was told by one buyer that if I could produce 5,000 pounds of yellow perch, he'd have a truck at my door tomorrow morning to pick them up. Because the wild harvest in the Midwest is gone, and the yellow perch is the basis for all of the Friday night fish fries in the Midwest, and apparently that's a very huge tradition out there. We're also looking at the brown bullhead, which people call the horn pout around here. Brown bullhead, one wouldn't think there would be much of a market for it, but again, I was talking to another buyer, and he said that he can move about 1,000 pounds of brown bullhead a week. And that's just through one buyer. He gets calls for it all the time from restaurants. They're looking for northern catfish to serve. So we know one grower that's growing brown bullheads in New Hampshire and pond culture, and so we're going to work with Melvin a little bit and see if we can start looking at that technology down here in our PAS system. We're also considering a couple of other alternatives. One, and these are going to be actually in the shallow water pond end of things. We figure we've got all of that surface area that, although it's primarily for phytoplankton growth, there is some options for growing plants and animals in there. So we've been looking at bait fish. The bait fish industry is a very large industry in Massachusetts, although no one really knows how large. And 99% of the fish that enter the bait fish market here in Massachusetts come from Arkansas. They're trucked up in live haul trucks on a weekly basis. And so we think there's a very good opportunity for native bait fish, either golden shiners or probably fathead minnows. We're also looking at crayfish. Crayfish have a number of different market opportunities with crayfish, and they're naturally occurring in the bogs, sometimes at very high densities. So we think that we might be able to look at crayfish as a commercial product. To go back to the unknowns, we're also looking at a production cycle. We're not sure what our production cycle is going to be. We initially were talking about a one-season grow-out where we'd stock these PAS systems in April and then hopefully have a marketable product by October and then shut the system down. Obviously, a shallow water, 1.5 deep pond is not going to overwinter in a liquid state, at least probably not. And so essentially these ponds will not work in the wintertime. So our vision is to run 9 months of the year and then shut it down for 3. So we have to figure out whether we're going to be trying to grow our fish to a marketable size within that one growing season or whether we're going to try to overwinter them somehow. And if we do overwinter them, where'd my overwintering come? What is that overwintering system going to consist of? Is it going to be in a building? Is it going to be in submerged cages in some of the deep makeup ponds that they have on the bogs? Just how are we going to deal with overwintering? We also have to deal with markets. And markets, the bottom line here is to make money. And so we have to look at a number of different markets and identify whether they are going to be able to purchase the fish that we produce. The best and the most attractive market is the live food fish market. You get very high dollars for live food fish, much more so than you do for fillets. So we're looking at, and there are some ethnic live food markets around, live fish markets. So it's a matter of investigating those markets and trying to decide whether we are going to be able to get a foothold in those markets, whether they'll buy the products that we can produce. We're also looking at a processed fish market, whole in the round or fillets. And one of the nice things about that is the fact that we have a very well-developed fish processing infrastructure in New Bedford already, so that we can try to take advantage of the fish processing plants down there if we do in fact look at a whole or fillet market. One of the real high money aspects of largemouth bass is pond stocking. You can sell a pound or pound and a half fish for somewhere between $10 and $15 to people a piece for pond stocking. So we're looking at pond stocking as a viable alternative. And then some of the other things, bait fish, the bait market. There's an interesting project that's going on down in Delaware where they're looking at one of their native crayfish species as a striped bass saltwater bait, and they're having very good success with that. And so we think if we can produce crayfish up here, we might be able to break into the saltwater bait market and probably get top dollar for any crayfish that we can produce. Freshwater mussels, there are a number of different freshwater mussels that are endangered. These are perfect systems for growing mussels in. There's lots of good food for them. There's lots of fish for that larval stage that requires attachment to fish. So there's good opportunities for growing freshwater mussels, although the technology is a little premature at this point. But there are people that are working very hard on growing some of the more endangered species of freshwater mussel for habitat restoration work in our freshwater systems. And then we're looking at ornamental aquatic plants. Water gardens are getting to be very popular nowadays. And every summer there's a whole new market because every winter everything dies, or much of it dies. So the ornamental aquatic plant market appears to be a pretty good market. And there is a lot of opportunity for growing ornamental plants in 1.5-foot deep ponds. The other thing that we've started talking about is wild rice production, which grows best just about at the depth that we're going to be maintaining our ponds. The problem with wild rice is that the Midwestern growers have pretty much locked up the seed supply, and it's very difficult to get wild rice seed to try planting it. But we have our ways, so we're going to try to start investigating that as a cultured product as well. And then the ultimate unknown is, can we make a profit doing it, or can the growers make a profit doing it? Beats me. We're going to set up a demonstration system at Brad's facility this summer. We'll start doing some research on it, looking at phytoplankton growth and populations to make sure that we can maintain what we need to maintain the water quality. And then from there, maybe next year, we'll try stocking some real fish in it and start looking at production and potential production rates using some of our unique native species here. So that, in a nutshell, is the partitioned aquaculture system. I've been going at 150 miles an hour, but I'd be happy to answer any questions that anybody might have. And I'm sure there's probably a few. Yes, Ralph?
In the Clemson studies, apparently the driving force for nutrients in the system is given as wastewater.
That's correct. Yep. When they first developed it.
Does that mean domestic sewage?
That was one of the things that they were looking at, yes. I didn't talk to Dave that much about that application for it, but he seems to think it has a huge amount of potential for sewage treatment. And that's actually the proposal that's up for the Everglades is to try, they're having a very serious hypernutrification problem in the Everglades, and so they're talking about installing these systems in some of the waterways off the Everglades to try to strip nitrogen out of the water.
Are you planning to use wastewater also?
No. We're going to we're hoping that the fish will be the source of the wastewater that we'll be needing to treat with our shallow ponds.
What are you going to do with the waste material that you clean out of it?
Well, all of that is approved for topical application for fertilizers. There are a number, we have 2 commercial fish farms in Massachusetts now that are generating, at least one of them generates around 20,000 pounds of fish per week. And they have contracts with local farmers out in Western Mass to do topical application of their solids waste that they dewater on site and then basically use a manure spreader and put it out on the fields. Yeah.
Potential for disease.
Whenever you have large concentrations of one species of fish, you always run the risk of having disease. That's just something that, with proper husbandry, you can minimize the risk. But I mean, that's a sort of a fact that farmers live with, from dairy cattle to fish. Yeah.
I was going to ask that, but I've got more. Would you have you gone up to the stage of, would the farmers be using the same cooperative, Cranberry Cooperative, Ocean Spray, and does Ocean Spray have the know-how to be marketing fish?
No. Brad, as you can see, elected to stick around for a little bit. Good thing. You want to field
No, that would not be part of the cooperative. This has nothing to do with the cooperative. The cooperative is where I market my berries. The actual cranberry bogs are my own, and that business is my own, as this would be.
Although that does not mean that there might not be potential for developing a fish marketing cooperative.
If we can prove this is a viable entity,
Yeah, 10 years down the road.
and we can get other growers in it, there's no better way to do business than a cooperative. But we're not at that stage yet.
Go ahead.
Do you have funding for the tests that you're doing on his farm, and do you have additional funding, and are you looking for additional test sites?
At this point, we have funding to build the demonstration project that we're putting on Brad's property. It's a combination of funding from the State Department of Food and Agriculture, my organization, the Southeastern Mass Aquaculture Center, which is a joint effort between Barnstable County and the Sea Grant program here, and also through the Ken Bergstrom's Western Center at Hampshire College. Those 3 groups are each ponying up a third of the cost to install this demonstration project. And then once we get the facility built, we anticipate being able to sort of sustain at least the initial trial periods using competitive research funding. So we will be writing grants that will be using this system as a basis for continuing the research on PAS application in more temperate environments than what most of the researchers are working on. Keep going.
Are you looking, have you looked possibly at using natural flow-through systems with proper baffles to strip the extra nutrient that would be coming out of the system? Have you looked at that? Because we have so many bogs in this part of Massachusetts that have flow-through systems that they share with other fish.
Yeah, I mean, the design for this system is essentially a closed system. It's not designed for an open flow-through application, and at this point, that's not in the cards. You know, we've got plenty of bogs that are isolated single units that we can work from, that we don't have to be looking at the flow-through bogs at this point in time.
And most of your bogs that are flow-through, it's not a constant flow-through. In other words, there's times during the summer where that water does stop, and that would be a difficult way to manage.
Go ahead.
Do you have a cost figure or an estimate of, I guess we do it per acre, of conversion of a bog to a fish pond by extrapolating from other systems?
We're in the process of putting the budget together for this demonstration project, and a very, very quick and rough back-of-the-envelope calculations. It's going to cost us, for the initial effort, around $35,000 to convert it over. I'm sure as we get, excuse me?
Per acre.
For this
system.
1.4 acre system that we're building. So it's, it's probably $25,000 an acre to convert it, rough guess. And that we will, the cranberry growers are a very creative bunch, and I'm sure that this system in 5 years is going to look absolutely nothing like what we're going to build this summer. And my guess is that they're probably going to end up fabricating most of this equipment and technology themselves. So that's going to seriously bring the cost down once the word gets out and people start seeing how this system functions, and then how to improve on it and how to make it more cost effective for them. Larry, we'll give somebody else a chance. Excuse me? Prepared diets. There are prepared diets that are available, appropriate for all three of those species that we talked about.
How was the flavor compared to wild?
I've never done a taste comparison, but what research I've seen on taste comparisons, there are differences that people can notice in the flavor between wild and cultured, but the flavor of cultured is not less preferred than the wild flavor. So, they taste different, but just as good. Yeah, Ralph.
Has Clemson managed to market any of their fish crop?
They're growing catfish down there, and they had just harvested that big 2-acre system before I got there, and I assumed that they went to a market. I didn't ask that question. The 2-acre system is fairly new. I think that was actually the first year that they had actually harvested a crop out of it. But they had that in full-blown production just before I got down there. Yes.
Is there any concern for residual pesticides from the cranberry growing?
That's one of the things that we'll be looking at this summer. We are going to put some fish in the system this summer, and we've put in our budget to do some analysis for residual pesticides and that. So we're going to be looking at that. We don't know the answer to that right now. It's potentially there, but it may not be, because many of the chemicals that they use have fairly short half-lives.
What about you're raising your own young fish to put in next year so you can make your...
Yeah, that's the next step. That's the next step down the road. That takes a specialized indoor facility, a hatchery. Right now, we're going to rely on commercial hatcheries and just buy fingerlings from them to stock our system. Obviously, and that's part of this concept of a cooperative, where you have 4 or 5 growers that all pitch in to the operation of